All right, let's jump right in. Have you ever wondered if the massive hype around unlimited, multi-page AI document processing actually holds up when you bring it home? Like when you take it off that specialized cloud-based hardware and run it locally on your own machine? Well, welcome to this explainer. Today, we're unpacking a really fascinating live evaluation blueprint. We're looking at a raw, in-progress testing skeleton that's designed to answer one massive question. Does unlimited OCR actually work locally on Apple Silicon, specifically on the Powerhouse M3 Ultra? We're going to break down exactly how this test is structured, step by step. Here is a quick look at the roadmap for our evaluation today. First up, we'll cover the Tuesday caveat. Second, our test setup on the M3 Ultra. Third, the multi-page stress test. Fourth, 3 core questions we absolutely have to answer. Fifth, the final verdict for Mac fleets. And finally, Section 6, the honest limits of this evaluation. Let's get to it. Starting off with Section 1, the Tuesday caveat. So, this entire evaluation stems from one nagging unknown. The quote here really hits the nail on the head. Does one-shot, multi-page mode survive the port off CUDA reference tooling? Basically, the original, mind-blowing results for this AI were achieved using native NVIDIA hardware. But as we all know, the real world of local developers runs on a massive variety of machines, heavily featuring Apple Silicon. The caveat we're cashing in today is simple. If we take off those NVIDIA training wheels, does this revolutionary multi-page mode just completely fall apart? And what's so cool here is how brilliantly this illustrates the build-in public mindset behind the source document. This isn't a marketing pitch, guys. It's a scientific field note. A positive result? Awesome. It means we have a viable pipeline component today. But a negative result? That is treated as equally publishable and highly credible. I mean, finding out a model breaks under specific local conditions actually saves developers thousands of hours of troubleshooting. In this context, a failure is just as valuable a data point as a success. Moving right along to Section 2, the test setup on the M3 Ultra. Okay, so let's look at the exact arena for this evaluation. For hardware, we are talking about the absolute top tier of local machines, an Apple M3 Ultra paired with a staggering 512 gigabytes of unified memory. Basically, a supercomputer sitting right on a desk. For the software side, the test evaluates open source staples. Think llama.cpp, LM Studio, or MLX. And it targets high-fidelity compressed formats from the GGUF repo, specifically Q8.0 or Q6_K. Recording these exact parameters is absolutely crucial because it's what separates a random anecdote from a fully reproducible scientific test. But, a test is really only as good as the data you feed it. Step 1 is our baseline, just a clean academic paper PDF. Step 2 turns up the heat with a table-heavy report, because tables are notoriously brutal for AI to parse without losing their structural integrity. And then Step 3 introduces the final boss, a German language document to test cross-lingual parsing stability. And get this, they aren't just doing single pages. The test throws these at the model in chunks of 1, 5, 10, and 20 pages. Which brings us to Section 3, the multi-page stress test. This right here is how you systematically break down an AI's capabilities. As you can see in the matrix, we have 5 distinct runs. Run 1 is our single-page baseline. Runs 2, 3, and 4 are the multi-one-shot tests, and they scale aggressively from 5 to 10 all the way up to 20 pages, all processed in a single massive prompt. The goal here is to see exactly where the model's brain starts to fracture under the sheer weight of the document length. Now, I want you to notice that final row, run number 5. It also tests 20 pages, but specifically as a page-by-page control. Why do that? Well, if the 20-page one-shot mode completely fails, we need to know exactly why it failed. Did the model just get confused by the complex German text, or was it the massive 20-page context window that caused the crash? Running those exact same 20 pages individually gives us a perfect control group to accurately compare against. It's just a brilliant piece of experimental design. To truly understand why the model might fail, we have to unpack a highly technical concept mentioned in the test framework, no-repeat n-gram logit processing. I know, it's quite a mouthful, but here's what it actually means for us. When AI models process really long documents, they have a tendency to start hallucinating and repeating themselves endlessly, kind of like a skipping record. This specific logit processor acts as a built-in safety rail. It looks back at a window of past tokens, 128 for single pages and a massive 1024 for multi-page, and it actively prevents the model from repeating any sequence of 35 characters. The critical unknown here is whether the local Apple Silicon runtimes even support this specific safety rail. because if they don't, the model might just descend into total madness. Because of that huge risk, every single cell in that matrix is tracking some very specific metrics. Does the run complete at all? If it does fail into a repetition loop, on exactly what page number does that failure start? If a complex table breaks across, say, page 4 and page 5, does the model successfully stitch it back together perfectly intact? They're also doing edit quality spot checks, measuring processing speed in tokens per second, and monitoring the peak RAM usage just to see how hard that M3 Ultra really has to work. All right, section 4, 3 questions to answer. So what does this all mean? Question number 1. Does one-shot multi-page work at all when taken off the reference NVIDIA hardware? The results are going to show one of 3 things. It works cleanly, it works but degrades starting at a specific page, or it's just a flat-out no, meaning without that custom logic processor we just talked about, it simply collapses into useless repetition. Question number 2. Where is the crossover? Let's say the one-shot mode works for a bit, but eventually degrades. This matrix is designed to find the exact page count where the quality of the one-shot approach drops below the quality of just doing it the old-fashioned way, the page-by-page control on that exact same hardware. Finding that specific crossover page number is absolutely gold if you're an engineer actually building real-world software. Next up, Section 5, the verdict for Mac fleets. The resulting article is going to lay out one of 3 potential verdicts that will really dictate the future of local AI on Macs. Verdict A, it's viable as a pipeline component right now today. You can start building with it immediately. Verdict B, stick to single-page processing only for now, just because multi-page is too unstable locally. Or, verdict C, we literally just have to wait. We must wait for the local runtimes like llama.cpp to actively build in runtime support for that specific no-repeat sampler before this becomes genuinely useful. And finally, Section 6, Honest Limits of Evaluation. The source document makes this super clear, stating, "This is a field note, not OmniDoc bench. It is absolutely vital to understand what this test is not. It is not a multi-million-dollar comprehensive benchmark across every device on planet Earth. It's heavily constrained to one specific hardware configuration, the M3 Ultra, one quantization level, and a small, targeted document set. Plus, it relies on spot checks, not automated scoring. By explicitly stating these limits up front, the evaluation becomes a flex of honest, practical reporting rather than pretending to be some absolute, infallible truth." To maintain that incredibly high standard of transparency, the skeleton outlines some strict house rules for publication. All terminal commands used must be version pinned and linked in a companion repo so literally anyone can reproduce the test. If the model fails into a repetition loop, they demand raw screenshots of the terminal output to act as visual verifiable proof in the final article. And the whole shebang must be neatly wrapped up in a standard 4-file package upon publish. Honestly, it's a masterclass in structured, transparent engineering journalism. Which leaves us with a final thought to ponder as we eagerly await the actual data to fill this testing skeleton. When these results are finally published, proving whether unlimited, one-shot OCR can truly run locally and stably on an Apple Silicon Mac, how will those incoming results reshape your own local document pipelines? Will it completely accelerate your projects or force you to rethink your entire hardware dependency setup? This is a space moving incredibly fast, and as this evaluation proves, the absolute only way to know the truth is to test it relentlessly. Thanks for tuning in to this explainer.